Hello, welcome back again with me, Christopher Fabian. Let me introduce myself before the video started. My name is Christopher Fabian. My student ID number is 21055311079, and my lecturer is Prof. Dr. Tjokorda Tirta Nindhia, STM. And today we're gonna talk about manufacturing process on chapter 3D until 3F. What we're gonna see on this presentation? So we're gonna talk about what operations on milling, and then about thread, and also about the last one we're gonna see on this video. The first one is milling. Milling is means of creating a desired surface with a rotating multi-tooth cutter. Each tooth of the cutter removes material as the workpiece advances against it. The axis of rotation of the cutter may be horizontal or vertical. The cutter can provide cutting action on its side or at its end, or you can say face or both. The cutter rotates rather rapidly and its position is normally stationary. The work moves past the cutter with a suitable depth of cut, a relatively slow feed rate. Milling is the most common machining operation for producing flat surface, but slots and contour or stepped surface and screw threads can also be produced. So we can say here, this is the conventional one. Remember, milling is creating of desired surface with rotating multi-tooth cutter. So this one is the cutter, and the workpiece is moved along the milling. So when the workpiece and the cutter is just stay like this and it keep like moving, sorry my alarm, and the workpiece is moved so it cuts like the surface. So that's the introducing of milling, and I have some video before we talk about everything on milling.
Plane milling. In this video shows the plane milling operation. Plane milling cutter. Workpiece. Plane milling are used for machining flat and horizontal surfaces.
So the cutter can be horizontal or just flat like horizontal.
This plane milling operation can be otherwise called as slab milling.
So remember, milling is something like you move the cutter
according to the relative movement between the table and workpiece. The plane milling machine can be classified as up milling and down milling. Up milling.
So that's all for the video first. Now we're gonna talk about face milling. Face milling produces a flat surface at a right angle to the axis of rotation of the cutter. Depending on the depth of the cut, some machining also takes place on the periphery of the cutter. For flat surfaces, face milling is generally preferable to peripheral milling from the standpoints of tool economy, simplicity of setup, and cutter rigidity. However, the operation is limited to flat surfaces. So face milling is like the normal one. So the workpiece is moved to this direction, and the milling cutter is positioned on horizon. So this is the cutter. If we see from this POV, so this one is the cutter, and the workpiece is right here. So the surface of this it gonna be cut by the milling cutter. Peripheral milling. The mill surface, if flat, is parallel to the axis of rotation of the cutter and is produced by cutting teeth located on the periphery of the cutter body. The operation is usually performed on horizontal spindle machines. The milling cutter or cutters are mounted on an arbor that has outboard support. The surface may be flat or contour, depending on the profile of the cutter. Flattened surface, contour surface, slots, and keyways are machined by this method. So if you can see here, this part it can be flat or counter, but depend on the cutter. So when you see like this, the cutter is like this. This is the cutter, and this is the work part. So the work part gonna be angle, become like this. So the work part gonna be like angle there. And milling uses a cutter commonly of smaller diameter with teeth in both end face. And periphery on figure 3D, this one and O, illustrates the operation. The approach is versatile in that slots, recesses, and profiles can be machined. Machining can also be carried out in areas not accessible to other types of cutters. However, the length or diameter ratio of end mills is high, and they can be supported only at the end. I mean, only at one end, so depend on the machine. However, so they are less rigid than cutters for other milling methods. Lighter fits may be required to reduce the cutter deflection, because it's very usually the workpiece is really hard, or the strength of the workpiece is really high. Material removal rates are less than with other milling methods, and accuracy may be not be as great as well. Because if you are using this one, when you cutting, and sometimes like you're gonna make like this the square, but because of this cutter, maybe sometimes it's become like this, like you have like this. So it's not really accurate, but it's good for smaller diameter. Slab milling. Slab milling is a peripheral milling with cutters that produce a flat surface over a wide area. The axis of rotation of the cutter is parallel to the machined surface. The cutter often removes large amount of material. Sometimes two or more cutters are used per arbor with opposing helices to balance cutting force. So if you can see here, this one, it's usually like with other, so the slab is like this, but the cutter it moves like, if we have two cutters, it moves like the one is clockwise and the other one is counterwise. The purpose of that is to reduce the amount of force by one cutter or two cutters, so it doesn't like really working hard for the cutters, and the workpiece is not gonna move to one side, but it's gonna stay like in the line. For milling, when the peripheral cutting edges of the milling cutter are ground with a form rather than in a straight line, that form is transferred to the workpiece as the milling operation proceeds. The operation is called form milling, and you can see the illustration here. Milling of gear teeth is common application of this approach. So the form milling, where is my pen? This one. The form milling is usually just using for the edge of some workpiece, and the form from the cutter is more like our focus on the cutter type. So if you can see here, it doesn't like just cut, but it gives like some lines, and the workpiece of the milling can be like straight line, of course straight line, because the cutter is stationary, and it can leave like some edges that we wanted. Gang milling is simply milling with more than one cutter on the arbor, like the previous one, like what I said on the different forces. This produces multiple surfaces of the workpiece with one pass of the cutters. Also see straddle mills as follows. We can talk about straddle milling later. So the gang milling is just like milling cutter with like more than one milling cutter in one arbor. Straddle milling. involves two cutters on the one arbor with a space between them. Two surfaces are cut in one pass, but the area between them is not machined. So the straddle different with the previous one because the space between them, of course, it happened in straddle milling, and usually the straddle milling is cut in one pass, so just one swipe. But in the previous one, you're gonna go one by one. Fly cutter milling involves the use of single point cutter rather than a multiple tooth cutter to perform a milling operation. It is face milling with only one cutting tooth. The method is useful for producing flat surface and clean. In a tool room situation where the optimal multiple tooth cutter may not be available, obviously cutting feed rates are much less than with face mills, but may be satisfactory when fly cutters are only tools available and requirements are only for one piece or a small quantity. So I have the video example for flying cutter. This is the work part. So you put the cutter milling on CNC machine, on milling machine, and you're gonna lock it. The cutter, you lock it so hard so it doesn't move when cutting. This is the working. Look, so the previous one, the work part surface is like not clean, like rusty. After the fly cutter milling, the work part surface is become clean and it's ready to use. Pin routing involves the use of template to guide the movement of a high-speed routing cutter or small diameter end mill. Typically, the process is used to blend flat stock of sheet metal or other materials. Stack of thin material can be cut by this method to produce multiple parts. I have the example of the guitar here, the wood work. So this is the router where it can be land here and it's gonna be cutting. So I have a video here.
I'm set up today to route the dishes and trays for the Dinner for 10 collaborative project. This is one I did a couple days ago. This is one of the end trays made out of cherry. I cut the parallelogram on the table saw, drilled the cove in the corners with a 3-inch hole saw on a jig in the drill press, burnt my little logo into the back, and then dished out the tray with this setup, the 1 1/4 inch diameter router bit with radiused edges, and then 1 1/4 inch diameter pin that I made from aluminum that goes in the table. Another thing I did earlier today is I made this little dust shield and hand shield to keep hands away from the bit and also try to collect some of the dust that's thrown by the bit.
You can see the video on YouTube. This is the title. I'm sorry because I don't know how to skip to the part of pin routing. Spot facing. That is normally used to provide small flat bearing surface perpendicular to the axis of a hole for a bolt head or nut. An cutting rotating tool is fed into the workpiece along the axis of the bolt hole, often with a drill press rather than a milling machine. Depth of cut is often not critical as long as the surface machine is flat and perpendicular to the axis of the bolt hole. The operation is the same as counterboring, except the depth of cut is shallow, only enough to create a flat machine surface. It is most commonly performed on casting and forgings, where the surface prior to the operation has some irregularity. So if you can see here, the spot facing is like you just cutting, but it's only happen on the spot, and it only happen on the surface, and it doesn't really depth. So when you're using spot facing, It only cut like shallow of the spot facing. Screw threads. Screw threads are made with a large number of different methods involving both machining or cutting and forming processes. Cutting methods include the use of hand-operated taps and dies for internal and external threading, and machines are single-point screw thread cutting, thread cutting by hands, thread milling, and thread grinding. Forming methods including rolling of external threads and cold forming of internal threads. So this is the difference between internal and external threads, and we're gonna talk about hand external threading. A typical external hand threading die is illustrated in 3E1. This is the picture. These are called butter or acorn dies and are useful for cutting screw threads in a prototype and limited quantity production. The die is placed on the end of the screw blank and is rotated with a wrench like a tool. It is fit itself forward at the lead rate of the screw as it cuts the threads. So I have a video here. You can see about how to cut an external die. So the hand die for cutting external is placed, and it's gonna cut the work part, making the thread. You just move it, just spinning like counterwise, because the hand die for cutting external is counterwise to make the thread. It's already threaded, and that's all. We're gonna continue to the next. Internal thread tapping utilize taps such as shown in figure 3A2. The tap is rotated like a drill or reamer and itself fed actually into the hole of the workpiece to create internal thread. Taps can be positioned and fed manually and rotated with a hand tool, or can be used with a drill press, lathe, automatic screw machine with a tapping attachment, or a special tapping machine. Tapping machines and attachment have the capability of reversing the rotation of the tap to remove it from the work after the thread cutting. Collapsible taps like this one automatically retract the cutters to clear the new threads and not have to be reversed for removal, but are not available for diameter less than a quarter and 11 and a quarter inch. So here are the video how to make internal threads. compression as well, so the edge isn't like sharp. So the cut is starting here for the inside cut, like the previous one, but the previous one is like the strip, you're gonna make the thread, but this one is you're gonna make like the thread inside the workpiece. That's all. Now we get into E3, single point screw threading cutting. It's a lathe operation, a firm cutting tool that has profile corresponding to that space or spaces between the required screw threads. Makes repeated passes along the workpiece, as you can see here. So the single point screw threads, it's from top point of view. So this is the hole, and the cutter is like this, and it moves like along this, so it cuts with moving single point tool. Thread cutting die hands, are efficient, accurate, and widely used in production thread. They are used on all kinds of lathes and screw machines, on drill press, and as part of special threading machine. As you can see here, this is a die head for external threads with inserted multi-tooth cutters. Now we're gonna talk about thread milling. This is like the explanation like the previous one. The difference is just utilize a form milling cutter, both workpiece and cutter rotate. So this is the video. I have this video. So this is the cutter, and it moves like what I said here. You can see it moves like radially and cut the diameter. So that's the point. We're gonna continue. Thread grinding. Thread grinding is used for when particular accuracy and surface. Just remember, thread is like you make the line, or where like you make fabric, and the grinding is like you cut or making it more like softing, like it makes soft. So that's the point of the thread grinding. Thread rolling. So the thread rolling is a cold forming method for making external screw threads. The blank workpiece is rolled between opposing dies. As you can see here, this is the blank, and this is the stationary die, and this is the moving die. So this is the work part. It's gonna be like rolled, and it's gonna leave some thread marks, as we can see here. Oh, this video has like both are die, like you cannot move. thread gonna be made by 2 rolls that pressing the upper part. That's all. We're gonna talk about cold form tapping on internal dies. Internal threads. It's just same, but you make it. And now we're gonna talk about broaching. Broaching is a high production machining operation that involves the one-way movement of a broach, a cutting tool with a series of progressively stepped teeth. The teeth move parallel to the surface being machined, and each one removes a precise amount of material. The action is similar to the saw, except that each tooth is set slightly higher than the one that precedes it and is wide enough to machine the entire surface. As you can see here, this is cut per teeth, so it cut like small, and the last one is gonna be more like deeper. As you can see here, this one, and the last one is more deeper. Internal broaching is machining by broaching the inside surface of a hole or other opening in the workpiece. The most common broaching operation is produced keyways, key slot openings, spline-shaped openings, and other non-wrapped round enlargement of holes in pulleys, gears, or other parts that are to be fastened to the shafts. So you can see here, this is the broach, this is already hole, and it's gonna be cut by the small hole, and the broach here, look at the saw, like the eye of the cutter. It's smaller, and the last one is get bigger. External broaching takes place when the broaching tools machine an outside surface of a workpiece. Example of the machining of flat surfaces, cam surfaces, and their other or ratchet teeth. You can see the video, like you can search it on YouTube. And pot broaching, this is the last one. Uses a ring or tubular shaped broaching tool with a cutting teeth on the inside. Normally the workpiece is pushed through the tool with hydraulic force. The tool cuts the entire workpiece very in one pass. Machining of gear teeth is a typical application. And you can see this one on YouTube as well, because my internet is gone now, so I can start the video. So that's all. Thank you for watching and see you next time.